Hi class, we're going to do 8.3 now. This is testing the differences between means dependent samples, and we'll be using the t-test. So these are the classic before and after studies. So we have a group of people, a measurement is taken, a treatment is applied, and then a new measurement is taken to see if the treatment had an effect. If I jump to an example real quick before going through all that, like this example, right? There's an SAT prep course, and then did that prep course help to improve the student's ability on the test, right? So for each student, we have a pair of scores before they took the prep course and then after. And we're just wondering if that course helped improve. Okay, so now we can talk about some different variables and that sort of thing. So there are some new variables in this section. N is just the number of students in the study. So really it's the number of pairs of data we have. When you see D bar, that's if you take the difference of all of those pairs and then find the mean. Right, so it's the mean of all of the differences. Mu sub D is the hypothesized mean of the differences. And what we're really concerned with these problems is mu sub D bigger than 0, less than 0, or equal to 0? I mean, is there improvement? Is there not improvement? That sort of thing. And then finally, when you see S sub D, that's the sample standard deviation, or just the standard deviation of all of the differences. If you subtract all those values, take the sample standard deviation, that's that value. When you set up your HOHA, it's going to be one of these three pairings. So notice you're always comparing this mu sub D to 0. Is there improvement, reduction, equal to 0? All right, so we have those three possibilities. It's always one of those three. Verification, that's an eye test. We just need random, dependent, and normally distributed population, or n bigger than 30, nothing new there. Here's our main formula, right? But that does depend on knowing D bar and S sub D, but really we'll be dealing a lot with raw data in this section. So for that, we'll rely on StatCrunch to make the calculations quicker. And then once you get past step 3, I mean, there's nothing new, right? We've done this a million times, I feel like. P-value method, same with rejection region method. You're probably tired of seeing that table. So a lot of the steps 4, 5, and 6 are nothing new. So let's jump right into this problem and see if we can solve it. The first thing we have to be careful about is defining mu sub D, in that which way are we subtracting? Are we doing the before minus the after, or the after minus before? That matters because that'll be the difference between positive and negative numbers. Excuse me. Typically, your textbook is going to default to before minus after, although it's possible to do the other way, and I think in problem number 5 it does go the other way. So look for the definition. It should be given in the problem. If you were doing a study just on your own, just research, you can just decide which way you want to do it, and it's just going to make the inequalities go one way or the other when you do your HOHA, which is what we're going to do right now. Okay, so in this one, the instructor's claim is improvement, right? So if we subtract in this order, before minus after, what would that result in? For example, let's look at that first student. Before minus after, 300 minus 400 is a negative number, and that indicates improvement, right? So if we subtract in that order, a negative number indicates improvement, meaning mu sub D less than 0 is actually this instructor's claim, right? Their claim is improvement, meaning before minus after would be a negative number, which is less than 0. So it's almost kind of opposite of what you would think, right? Because we have improvement and then we have less than 0. Okay, that's one confusing part. It's a left-tailed test. Now once we get to that stage, what's next is we're just going to use StatCrunch to get our statistics. Okay. Let's see. So I've already done a little bit here, but I'm going into my groups, and it's this problem SAT prep course. So I load the data into StatCrunch, right? That would be step 1. And then where we're going is stat, T-stat, right? Because we're using the T distribution on these, and it's paired data. So it's that third one down, paired. And then my sample 1 is the before, my sample 2 is the after. Because now by default, StatCrunch is going to be column 1 minus column 2. All right, so make sure it's always just column 1 minus column 2 when you enter it, and you're good. And then notice that column under save differences. That's a really good column to click because we'll need that column later. What that does is subtract the pairs and then records the difference of each pair. For HO, leave that 0 all the time for these, and then HA, match what you just wrote down, which was less than. It's always nice to show the critical value in case you need it in my lab. So this one is a 0.01 significance level. And that's the setup. Click compute, and everything works out really nicely. We get the T-stat, the critical value, the p-value. All of those are accurate, nothing weird going on in this section. So I can jot those down. On my handout, we had the test statistic as negative 6.80, the critical value, T sub 0, negative 2.82, and the p-value was just super small, less than 0.0001. Okay, and then once you have that information, you know how to make a decision, right? I always default to p-value if I have it. That p is so small, it's definitely less than 1%. So when the p-value is smaller, that's reject h sub 0. And so reject h sub 0, there's always sufficient evidence. And the claim is HA, to support the claim. Right? Sufficient evidence to support the claim will be my final answer. One thing that they might ask you for as you're going through homework, which we never had to find because we use StatCrunch, are those two values, the D bar and the S sub D. That's why when I did the hypothesis test, I clicked that box, save the differences. That will help to get those two values. Because the D bar is the mean of those differences, and the S sub D is the standard deviation of those differences. So if I go back to StatCrunch and I close this report, look at that third column now has appeared. That is the differences of all the pairs. And what I want is the mean and standard deviation of that column. You've done that way back in chapter 2. So to get those values, go stat, and we're going to do summary stats. Remember that back from chapter 2. Summary stats of a column. And then we just got to select the column. It's the differences. And then we just click compute. And it gives me the mean, negative 60, and the standard deviation, 27.888, or so, 27.9. Okay, so I can go back to my handout and record those, or type them into my lab, and I'm good to go. Okay, and that's a complete before and after problem. Let's try another one. Here's one where we have a physical therapist suggesting that a treatment helps to reduce the length of patients' headaches. Okay, and so that's what we have in the data. Is there enough evidence to support that therapist's claim? So again, we're going to do mu sub D is before minus after, because that's how most problems are completed. And that's how StatCrunch really does it. And then we can get our HOHA. Right. So now look at, usually you can just look at a patient and piece it together. If you do before minus after and there's a reduction, then notice that number is positive, right? 2.8 minus 1.6 would be a positive number. So the claim from this physical therapist is that mu sub d is greater than 0. So again, it has that opposite feel, right? Reducing translates to a claim of greater than 0. Okay, so this is a right-tailed test. And we're going to get all the numbers. So I've got to load the data. There we go. So let's close that problem. We'll just go back to my groups. So I think I have this one in there. Just going to go find it. It's on page 2. There it is. So headache times. So load the data. And just like we did before, stat, t-stat, paired, before in sample 1, after in sample 2, save those differences, always leave the HO 0, but make sure to get that inequality correct. So this one is greater than 0. And show critical value in case we need it. This one is a 5% level of significance. So we're good. Okay, there's the setup. I click compute, and I get everything I need, mostly. All right. So again, we have a super small p-value. I'll go to critical value, t-stat, and I'll go jot all that down. Okay, so from StatCrunch, I got t is 6.28, t sub 0, 1.81 about, and then p, super small. Okay, so again, I know because p is so small, it's less than 5%, that's a reject. H sub 0. And HA is the claim, so this one's the same as the last one. Sufficient evidence, because we rejected H sub O to support the claim. Okay, and we're good to go. That's it. Now notice again, the only things that are missing are the D bar and the S sub D, and my lab will ask you for those. So you can go back to StatCrunch to get them. Just go close that out. You got your difference column now that appeared because you clicked that box. And now it's stat, summary stat, column, select your differences column, and then that's all you gotta do, compute. And that'll give you the mean, 1.18, and the standard deviation, 0.62. So I can put that in my handout and I'm good to go. All right, and that's that. Now, the one little thing that could happen is that they will reverse the before minus after thing. And let me show you a problem that happens. There's just one in your homework. It's this one. It's problem number 5 in 8.3. Oh, my session has ended. Okay. Well, that's fine. I just wanted to show it anyway. So notice on this one, it does before minus after, or right there, and I'm trying to point out, or June minus May. So it's column 2 minus column 1, and that kind of reverses everything, right? So this one, it's that very top sentence. A reporter claims that the U.S. gasoline prices increased May to June. So if there's an increase from May to June, but then you subtract June minus May, you should get a positive number. That's why the correct answer is that one, right? Because that's showing a mu sub d greater than 0 on the HA. Now, when you pop these things into StatCrunch to get the numbers, I would just, to do it, reverse the columns for sample 1 and sample 2, right? So, let's see, can I just open that in StatCrunch real quick to show? Hopefully that works. It's checking my credentials. Okay, so I load that in there, and then when I do my stat, t-stat, paired, right? Typically you do column 1 in sample 1, but I'm going to reverse it. I'm going to put June in that one, and then May in that one. And then that'll help solve it. Okay, that's one way to do it. Okay, well, try that out, see if it works out. I mean, oftentimes if you get it reversed, your p-value is going to be like 90%. If you get a p-value that's super high, probably just means your columns are reversed or your inequality is reversed or something like that. So you can play around with it until it works out and you'll get a good feel for it. Okay, otherwise I hope all goes well. If you have any questions on 8.3, send them my way. Otherwise, I will talk to you later. Thanks, bye.